Welcome to Math Supervision. Today, we're going to learn how to find the determinant of a 2 by 2 matrix. So determinant of a 2 by 2 matrix. A 2 by 2 matrix is defined as follows. A 2 by 2 matrix is defined as A, which is equal to the elements of A, which are enclosed within two brackets, an opening and closing brackets. So A, B, C, and D are the elements of matrix A. The determinant of matrix A is denoted by det A, or A within two vertical bars. It looks like the absolute value of A, but that is the notation for the determinant of A. The determinant of A is found by multiplying. So you start by drawing the two vertical bars and then multiplying the elements on the leading diagonal. So you multiply the elements on the leading diagonal and subtract out the product of the elements on the other diagonal. So in other words, you get your determinant to be the product of A and D minus the product of B and C. And this determinant should not be equal to 0. If the determinant of A is equal to 0, then matrix A is singular. Another way you can say singular is non-invertible. So whenever you're given a 2 by 2 matrix, notice that the process of finding the determinant involves expressing exactly what you intend to do, and that involves placing the elements within two vertical bars and then multiplying out the elements on the leading diagonal and subtracting out the product of the elements on the other diagonal. We say multiply the elements from the top left corner to the bottom right corner and subtract out the elements from the bottom left corner to the top right corner. So you multiply those elements and subtract them out. And that should give you the determinant. So just as expressed. And if you end up with a determinant of 0, then you must conclude that the matrix is singular. And if a matrix is singular, we say it is non-invertible. A non-invertible matrix is a matrix that has no inverse. We will ultimately, in our next presentation, show how to find the inverse of a 2 by 2 matrix. So let's look at some examples. Find the determinant of each of the following matrices. And conclude whether the matrices are singular or not. So matrix A consists of the elements 1, 3, 2, and 4. And matrix B consists of the elements 6, -3, 4, and -2. So here are the solutions. So the determinant of matrix A is equal to, so you place the elements within 2 vertical bars, and then you indicate that you're going to multiply out the elements on the leading diagonal and subtract out the product of the elements on the other diagonal. So this should give you 1 times 4 minus 2 times 3. So that gives you 4 minus 6, which is -2. And this is not equal to 0. So matrix A is non-singular. We go to B, so solution. So the determinant of matrix B is equal to, so you specify the elements within 2 vertical bars. So this is the notation for the intent to find the determinant. And then you multiply out the elements on the leading diagonal and subtract out the product of the elements on the other diagonal. So this gives you 6 times -2 minus 4 times -3. And this gives you -12 plus 12, and this is 0. Therefore, we can conclude that matrix B is singular. So that's it. That's how you determine the determinant of a 2 by 2 matrix and conclude whether the matrix is singular or not. So next time we will see how we can use these determinants to find the inverse of a 2 by 2 matrix. Thank you. See you next time.